you guys excited for Builder Night? Awesome, awesome. Despite the heat, despite the flood, like everybody's here, huh? And we are really appreciating that. Cool. So, who has been already to a Builder Night? Okay, cool. Some people. Okay. How many developers do we have in the room? So Nader can fine-tune his talk. Cool. So, as everybody know, like our Builder Nights are vertical-based, right? So we'll speak about specific verticals. Sometimes we spoke about 437. Sometimes we spoke about 6900 less Denver. We spoke about layer 2 in Istanbul. And yeah, tonight is all about risk-taking, right? How many people are currently full-time in a risk-taking company? Okay, cool. Okay, cool. It's very interesting. Obviously, you're biased. Come on. So, okay, let's invite on stage Nader to speak about Eigenlayer for developers and the tooling around the ecosystem that you have today. And yeah, excited to be here. Agenda is quite quick. The goal is to network between other builders. We will have this small keynote, then we do a quick break, and then we have a full risk-taking panel. And then we just network, we stay outside, we enjoy in the evening, and we just care that we are safe even after a one-day flood. Okay, cool. So, welcome, Nader. And yeah, a big round of applause. And yeah, you guys excited about that? And make sure that we're asking some cool, spicy question after his talk.
Woo! All right, so thanks for everybody who came and braved all of the crazy rivers and streams and swam here, or however you got here. Luckily for me, I'm working and staying right across the street. So I just walked over here. It's pretty nice, even though I was stuck yesterday in all of the madness. Thankful that today seems like a beautiful day. Hopefully it'll clear up and everything like that in terms of all the traffic and everything. Today I'm going to be talking about Eigenlayer from the perspective of a developer. When I first learned about Eigenlayer, it wasn't that interesting to me because it sounded more around finance and that areas that weren't really that fine-tuned to me as someone who got into this whole space to build applications. But the more I learned about Eigenlayer, the more I realized that it actually was very, very impactful and relevant to what I actually cared about. So I want to kind of talk about it from that perspective. My name is Nader. I've been doing developer education for 10 years. I've been a software developer for 12 years. I've worked at AWS for 3.5 years on the mobile and serverless team, focusing on full stack serverless, full stack cloud development. I've been in the blockchain world for a little over 3 years now. I've worked with Celestia, I've worked with the Graph, I've worked with Aave, and I've been with Eigenlayer for less than 2 months. I first met Sriram about 2 years ago, though, and I heard about Eigenlayer then. I've been keeping up with it during this time, and I'm very fortunate to be working with that team now. I'm going to be sharing a lot of stuff, but if you want the TLDR and you want to kind of go back and learn about some of the stuff that we talked about here, this is a great list of resources. You can also go to docs.eigenlayer.xyz. There's a resources page, has a lot of really great introductory level content as well as intermediate and advanced level content. There's a really great Boys Club episode where they interviewed some folks from Eigenlayer. I think that's a good introduction if you haven't already heard about that. So, to kind of like start this discussion, I want to kind of propose the reason why Eigenlayer seems so interesting to a lot of developers. The challenge right now is that if you want to build a protocol or if you want to build any network that requires some form of verification, you have to bootstrap your own economic security. And if you look at the innovation that kind of happened when Ethereum or the first smart contract blockchains were introduced, it was groundbreaking because anyone in the world could just write some code and deploy it, and you had an application and it was permissionless. It was very, very different from anything that you could have done in the past in terms of building software, because in the past, as I'm going to dive into more, if you wanted to build a decentralized application, you literally had to build a brand new blockchain to facilitate that. With smart contracts, you can kind of deploy and inherit this security. But if you want to build anything that is not a smart contract, if you want to build another protocol, you can't just write a smart contract. You actually have to build a completely new blockchain or chain or protocol or whatever you like to call that from the ground up. So the TLDR, and I like TLDRs a lot. and I'm going to be using TLDR because sometimes we go into too much depth about some type of discussion when in reality you could kind of sum it up. But to sum up what I'm trying to say is that bootstrapping decentralized infrastructure is difficult. And actually, bootstrapping any type of infrastructure is difficult. We worked with so many teams at AWS that would spend months and millions of dollars trying to shave off hundreds of milliseconds off of their latency for their application because that meant like millions of dollars more in revenue for them. We spent days and weeks debugging infrastructure, finding bugs that we couldn't figure out that were causing their infrastructure to have downtime. So having some type of reliable network is hard enough. Making that decentralized is even, an order of magnitude harder than that. But if you look at what is the most stable software system in the history of the world, you could kind of like possibly say that Ethereum is. It's one of these only software apps that has been around and has worked for 10 years or so. And if you kind of look at, even at AWS, US East 1 goes down on a yearly basis, and all of the applications that support it go down. If you're running your own servers and things like that, you have more control, but still, there's so much complexity in these decentralized infrastructures and infrastructures in general that it's just really hard to kind of keep anything up. So Eigenlayer is a protocol that helps facilitate the answer to make these challenges easier. It's a protocol built on Ethereum that introduced this idea of restaking. And restaking is a means to an end. And the means to the end is that it brings the power of Ethereum outside of the EVM to additional applications that would have traditionally had to have been built from the ground up. So the TLDR could be shared security for Ethereum or increasing the programmability of Ethereum. So right now, the programmability of Ethereum is smart contracts, right? But what if we could say we want to kind of extend that to any protocol in the world, anything that you can possibly think of? And that's what an AVS is, and that's what we're going to be diving into. But before we get there, what does shared security actually look like in practice, and what is the history of shared security? So to understand that, let's look at the evolution of blockchain networks. The original and a few of the other ones that looked like Bitcoin were these, I would say, application-specific networks. So we had Bitcoin, and then we had Litecoin, and we have all these other similar blockchains that were mainly meant to facilitate some type of payment transfer, but in reality, it's more of like a ledger that keeps up with transactions. You couldn't actually write your own application. You could use that blockchain for its specific use case, but you couldn't actually say, oh, I want to deploy an app to Bitcoin. If you wanted to deploy a new blockchain or a new app, you had to literally build a new blockchain. So the next thing that happened after Bitcoin and these blockchain-specific, or these application-specific blockchains were smart contract networks starting with Ethereum. This is kind of like paved the way for Web3. So anyone that builds on Ethereum or Solana or these other smart contract blockchains is inheriting the security of the underlying network. So the reason that people build on these networks, there's a variety of reasons. You have distribution built in, but the very, very key primitive is the security that you inherit from the network. So now we have this base layer that is Ethereum, and then you have the EVM that's built on top of that, and then you have all of these different applications that have been built on top of that. And all of these smart contracts are then composable. Anyone can kind of build on this. So this has been a very massive wave of composability and innovation that we're all probably here because of. But what we're realizing now is that these, at least for the most part, I think most people have come to this consensus, is that if you look at the amount of throughput and the amount of usage in traditional like Web 2, it's like orders of magnitude more than any blockchain that exists today. So we've focused on vertical scalability, making the VM faster and more performant and cheaper and things like that. But at AWS, we had a database called DynamoDB. And we had single applications that were hitting 100 million operations per second that were a single application. that were only used by a single application. And if you compare that with what could be considered some of the fastest blockchains in the Web3 space, let's say Solana, for example, let's just say that they do actually have 10,000 TPS. This 10,000 TPS is shared by every application deployed to it and every user of that application. So if you compare that to the 100 million operations per second of DynamoDB, we are nowhere close. So how do we solve that? I think that the consensus is that we are needing to, we want to continue to scale vertically. We want to make the execution environments faster, cheaper, better. But with the kind of evolution of what the roadmap even of Ethereum has laid out is we're now scaling horizontally as well. And the way that that's being done is rollups. So you have batch transactions that are posted to an underlying L1, and then you have L3s that are being talked about and even being built, and people are talking about layers on top of that. So now you kind of have a way to scale this, right? So what you have kind of seen talked about in this fashion is this idea of like modularity, where we're kind of like decoupling everything. And this is enabling this horizontal scaling. So with rollups and other infrastructure, we're starting to see horizontal scalability, but we're also starting to see a lot more specialization. So if I can choose my data availability layer and I can choose my execution environment, you might also want to choose your Oracle, and you might also want to choose all these other pieces within the stack. And if you're building something that's differentiating, if you're not just copying something else, you might want to change something to make your blockchain more interesting and useful for that use case. And how do you actually do that? Well, you continue decoupling the stack. And to decouple the stack, we need more protocols to enable that. So we need more oracles, we need more bridges, we need more what you might call co-processors. All these different pieces need to be built. But if you need a new protocol and you want to make it specialized, how can you actually make that work when you need to bootstrap sometimes billions of dollars of security for something that might be only used by a small subset of people? And to do that, to bootstrap this new network, you need to have all of this, this underlying infrastructure built, and you need to bootstrap security with stakers and operators. This is a very, very massive task. We've seen networks that have been built that take years to do this because it's not easy. And a lot of them still fail because it's so challenging. So here's the question. What if developers could access Ethereum validators without making them stop validating Ethereum? So the answer is what Eigenlayer is all about. It's this idea of these actively validated services, and they allow you to deploy decentralized infrastructure without having to bootstrap a new network. So in the past, this is kind of what it looks like to build a new network. You have your base layer that someone might be building with like smart contracts. You have your dApp. And then if you want to build a new network, like an Oracle or something like that, then you have this brand new blockchain or whatever network running. Now, if someone's staking Ethereum here and you want to draw them into your new protocol, you launch a token, and then you ask them to buy your token. So what does that mean? That means they have to essentially exit some other place or have some liquidity come from somewhere else, and then they use that to buy into your new network, which is often volatile. It's very hard to maybe find the token. So in order to do that, you often see these new networks having a lot of very expensive security, I guess you could say. The difference now is what you can do is you can take this new protocol and you can allow people to take the Ethereum that they've already staked, and then they're restaking that to verify your network. They are continuing to receive rewards for validating the previous network, but they're now earning additional rewards from the new network. So this is kind of what the network participants look like in Eigenlayer. You have Eigenlayer sitting at the middle with the Eigenlayer contracts. You have the stakers who are staking to operators. The operators are opting into different ABSs. The ABSs are deploying to Eigenlayer, and then the app developers are building on top of these ABSs and rollups. You also have this idea of dual staking. So if you are thinking, what if, if Ethereum is already being used for validating my network, then what's the point of having a token? Well, it actually makes even more sense to have a token in this case, because you're not issuing so much token rewards that you are having to pay like so much for the security. You're still able to issue token rewards, but people can essentially do things like stake Ethereum. They can also stake your token, and you can issue rewards in whatever token that you would like. So that's called the dual staking model. And if you look at some of the resources I shared earlier, we have more details on how that actually works. So another TLDR about what an AVS is. It's an app that uses Ethereum Trust, but outside of the EVM. What are some of these categories? Well, they really don't fit perfectly inside of these different categories, because I could almost call all of these roll-up services. But we have seen a kind of a lot of, I would say, patterns with what people are building, and they all often fall into these categories. We have roll-up services, we have coprocessors, we have cryptography, we have proofs, and then we have this other category, which is everything else. We're seeing a lot of like AI stuff and decentralized storage and oracles, I would say, go into this other category. And the first AVS is EigenDA, which is a data availability layer, which has already gone live. So what are some examples? I mentioned EigenDA. EigenDA decouples data availability and consensus. Some of the differentiating factors about EigenDA: very high throughput, very low cost, but you can actually reserve bandwidth. I think what we've seen with blobs is that they're very variable in terms of cost. What if you could say, okay, I want to reserve this amount of bandwidth, therefore you know exactly how much your transactions are going to cost regardless of any spike in throughput. Reminds me kind of serverless technologies and a similar spirit. Some other AVSs. So we launched 6 AVSs were launched onto Eigenlayer last week. Some of the interesting ones that are being built are Versatis. Versatis is a combination of a bunch of different AVSs, but one of the ones the first thing that they've launched is actually a roll-up on EigenDA called Laser, language agnostic stateless roll-up. The interesting thing about this is that they have enabled developers to build smart contracts or write smart contracts using more common programming languages. So JavaScript, TypeScript, Python, Rust, and things like that are supported. And then they're also building out different AVSs to support other cloud services. So a compute AVS, a functions AVS are being worked on now, and they also have plans to build out other things like database and CDN and stuff like that. Another example are coprocessors. So with the idea of the modular stack, the first thing that was originally decoupled was data availability, but we're now seeing a massive decoupling of a lot of other parts of the stack. So Lagrange is essentially a coprocessor where you can actually use this AVS or this protocol to do computationally expensive tasks. And you can use it almost like a microservice in the sense of a traditional infrastructure. We have this idea of restaked rollups, and there's a lot of rollups as a service that are built on EigenDA, but the interesting thing about AltLayer is that they are not only a rollup that is deployed to EigenDA, but they've also deployed a couple of AVSs that support different pieces of the stack. So they have sequencer network and a few other pieces, and this is kind of one of the more interesting and exciting, I would say, AVSs that launched last week as well. There are quite a few different rollups as a service that are leveraging EigenDA: Caldera, Conduit, Gelato, all examples of that. Excuse me, I'm losing my voice now a little bit, but Mega ETH is really interesting to me. As someone that's been excited about Monad, I think that this is essentially a very similar approach to building a very high throughput EVM. They plan on launching at 10,000 TPS, and they want to scale out to 100K TPS soon after that. And using EigenDA, we've already worked with a few teams that were able to hit similar numbers. So I think that Mega ETH is in a very similar category to some of the things that I'm kind of interested in terms of like building out high throughput networks. EVM compatible, EVM equivalent. They're doing stuff like parallel processing, but I think that some of the other stuff that they're doing is actually just as important. They're rebuilding the database and everything like that. So if you want to learn more about all the different ABSs that are available, you can go to eigenlayer.xyz, click on ecosystem, and you'll see that we have a list of all the ABSs that are either currently announced or deployed, and we're going to have a handful more that are coming out over the next couple of months. This is an interesting post by Tarun. He mentioned that after going to a few college hackathons recently, it's clear that no one has caught technical students' attention quite as much as Sriram and Eigenlayer. So I thought that was a really cool post. So I've just included that here. Anyway, that is it. If you have any questions, me, Sue, and Wes are all here from the Eigenlayer team, and we'd be happy to chat. Thank you.
Oh yeah, it's working. Cool. You guys wanna any question to Nader? Could you talk a little about Eigenlayer endangering the Ethereum ecosystem as a whole?
Excuse me?
Could you talk a little about Eigenlayer posing a challenge or security issues with the Ethereum ecosystem as a whole?
I'm sorry,
Could you talk a little about Eigenlayer posing a security issue for the Ethereum ecosystem?
Okay, the question is, can you talk about Eigenlayer imposing some type of security issue or risk for the Ethereum ecosystem? Yeah, we've definitely actually talked a lot about this, and this has been a very public discussion actually, not only within our company, but on social media. There's been a lot of, I would say, research and things like that has gone into it. I would say the best way to answer that question, to kind of give all of this really deep dive layout when we have the answer to that, would be go to our risks and FAQ documentation. And I would say a lot of these Q&As around the things that we would answer to that question are all already laid out there. So I think it's better to kind of go there and get that question answered there. Or, I would say that also if you want to get in touch with some of the team and have more specific questions about what you want to know, we can maybe answer that, but that would probably be my answer. So,
one last question.
Hello, thanks for the talk. What developer initiatives are you running at the minute, and how are you helping developers on board to Eigenlayer?
I'm sorry, can you repeat the beginning of that?
What initiatives are you running at the minute for developers? Secondly, what areas can
Okay, got it. So the question is, what initiatives are we running for ABS developers, and what areas am I most excited about? Some of the initiatives that we have built, I'm still fairly early, but my role is developer relations, and the whole point of our team is to make developers successful. So a lot of the focus that we're working on is between three categories. We have teams building on EigenDA, teams building ABSs, and then teams building on top of ABSs. We've rolled out a whole developer support program where we do documentation reviews, we do weekly meetings, we do developer relations support, we do awareness, blog posts, Twitter threads. We're also doing a lot of work in trying to build out high quality reference architectures, and really hopefully trying to foster an ecosystem where we have more SDKs and more starter projects, I would say, for building an ABS. So all this is already happening. We're also building out two specific interview series where we deep dive into architectures that are being built on Eigenlayer. One is like a whiteboarding series, and one is more like a higher level interview series where we ask questions about their experience building on Eigenlayer. So we're kind of trying to do public-facing educational stuff, but also one-on-one developer support. And that, it seems like a lot of the teams have appreciated that. So, for instance, Versatis mentioned here, we've dived into their documentation, we've dived into their SDKs, and we've dived into a lot of the things that they've been putting out. We've been giving them a lot of feedback around how they can improve that. The things that I'm most interested in, I think that I'm really interested in this whole roll-up as a service category, because there's just so much that's being spun out of that is really hard to kind of predict. So we're seeing very specialized networks being built, and with that, this new kind of co-processor category is very interesting, because Lagrange is, I think, one of the first ones that's been built in that space, and they're having a lot of success. And all the things that you can do with that are still yet to be determined, but they're kind of interesting to me. So yeah.
Sweet. Awesome. Thank you so much, Nader. We have a lot of pizzas coming around. We're doing a quick break of 10-15 minutes, and then we're coming up with our risk-taking panel and ABSs. Thanks, guys.
Woo!